Hello everyone. So this is Engineer Jana May Domingo from Summer State University, College of Engineering, Civil Engineering Department. So I am going to discuss about the chapter 1 of the differential equation, which is all about the definition. So the topics includes the introduction, solution of differential equation, order and degree, and the solution of differential equation. So for the introduction, in engineering and science, mathematical models are developed to aid understanding of physical phenomena. This model often yield an equation that contains derivatives of a known function. Such an equation is referred to as differential equation. Next topic is the differential equation, ordinary and partial. So what is a differential equation? So that is an equation containing the derivatives of one or more dependent variables with respect to one or more independent variables. So it is divided into two types, which is the ordinary differential equation and the partial differential equation. So when we say ordinary, that is an equation containing the derivatives of one or more dependent variables with respect to a single independent variable. While the partial differential equation is an equation containing the derivatives of one or more dependent variables with respect to more than one independent variable. So let us have two examples. So in this example, we are going to identify if the differential equation is ordinary or partial. So what do you think is the first example? Is it an ordinary or a partial? So for the first example, that is an ordinary differential equation. How about the second example? So that is the partial differential equation. So how can we distinguish what is ordinary and what is partial? So for more examples, you can read the reference book I'll be giving at the end of this slide. So let us first distinguish the difference between the two, between the ordinary and the partial. So first, you can see that in the ordinary, we use the symbol for derivative as d over dx, while for partial, we use this. So that symbol says that you are having a partial derivative. So next, another another characteristic of an ordinary partial derivative is that we only have a single independent variable. So the independent variable is the denominator. So for the first example, you have only dx as your independent variable. So you have a single independent variable. While in the partial derivative, as you can see, you have three independent variable, namely the x, y, and z. So that is the difference between the ordinary and the partial derivative. So for more examples, again, you can read the reference I will be giving in the end of this discussion. So let us now move on to the next slide. So we have the order and degree of differential equation. So for the definition of order and degree, order of a differential equation is the order of the highest derivative present in the differential equation. So it is the order of the highest derivative present in the DE. while the degree of the differential equation is the degree of the highest derivative present in the differential equation. So, let's solve the examples. So, we need to identify the order and degree of the differential equation. So, to do that, let us first take a look in the first equation. So, what is the order? So, the order is what derivative is the highest derivative. So, as we can see, the highest derivative here is the y prime. So, that is also equivalent to dy over dx. So, what is the degree of this equation? So, we are talking about the power of the derivative. So, the derivative is raised to what power? So, as you can see, that is only raised to 1. So, in summary, the first example is first order, first degree. While the second example, the highest derivative is the third derivative, since you can see that it is the third derivative, that is the third order. So if you can see number 3 at the derivative, so that is in third order. And what power is the derivative raised to? So as we can see, that is only raised to 1. So we can say that the second example is in third order, first degree. While the last example, the highest order is at the second derivative. So, second derivative is the highest derivative. So, that is in second order. While the power of the second derivative is only raised to 1. So, that will be equivalent to second order, first degree. So, the answer is second order, first degree. So, for further information, the degree I'm talking about is the power. The power which your derivative is raised to. But since second derivative is the highest derivative, and then we need to get the degree of that highest derivative, and that is your equivalent degree for the whole equation. So next, for more information or for more examples, you can read the reference book at the end of this discussion. So let us now proceed to the solution of differential equations. So this is the last topic for the first chapter. So solution of a differential equation is the relation involving only the variables and the arbitrary constant, free from any form of derivative or differential satisfying the differential equation. So we have two types of solution. We have the general solution. So when we say general solution, that is a differential equation which is non-derivative equation that contains an undefined arbitrary constant. While for particular solution, it is a non-derivative equation in which the values of the arbitrary constant are determined. So, for this topic, we have the example that x dy plus y dx is equal to 0 when x is equal to 1 and y is equal to 2. So to to solve for the general solution, we need to divide both side by xy, or in short, I think you need to find a way on how you can eliminate the derivative in the equation. So in this example that I'm going to show, this is my way to eliminate the derivative. So on how we are going to find the solution for a differential equation that will be discussed on the next chapters of this subject. So let us not focus on the solution but on what is general solution is really is. So we are defining the general solution. So let us just stick on defining what is a general solution. So I'm just going to show a whole solution just to explain what is a general solution. So for this example, so you need to divide both sides by xy in order to make a equation that is pwedeng ma-solve through integration so that we can eliminate the derivatives. So dividing both sides by xy, you will be having an equation dy over y plus dx over x. So we need to integrate the equation to eliminate the derivative because as we define solution, that is an equation wherein there is no derivative. So a solution is an equation with no derivative. So let us integrate the equation. So the integration of dy over y plus the integration of dx over x equal to 0. So by integrating, you will have ln x plus ln y is equal to c. But we can also express it as ln x plus ln y is equal to ln c. So whatever you put in ln c, that is still c. So c here is the arbitrary constant. So so we can solve for the final general solution, we need to make this kind of stuff. So I guess you have learned this on your integral. So I hope you have learned this, or you might want to review your integral so that you will recall how to answer, integrate, and solve for the final answer. So remember that when you integrate, you will be having an arbitrary constant. So we have a final answer that xy is equal to c. So xy is equal to c is your general solution. Now, if you try to substitute the value of x and y into that general solution, that becomes a particular solution. So if we try to, so we have a general solution of xy is equal to c. So if we try to substitute x, which is 1, and y is equal to 2, and you have c is equal to 2, and you say x, y is equal to 2, then you had solved for a particular solution. So for more examples, read the reference book after this slide. So this is the end of the discussion, and this is my reference book. So this is a book of J. Perante, W. Perante, and F. Kumba, 2014, titled Differential Equation, second edition work textbook. So I hope you learned something from this discussion. Thank you for listening.